We're going to look at a two-sample t-interval for the difference of two proportions. So in a recent experiment, 250 volunteers with arthritis, randomly assigned, receive either a new pain pill or a placebo. So that's important information, randomly assigned. Of the 150 people who received the pain pills, 48 reported decreased arthritis pain. For the 100 people who received the placebo, 21 reported decreased arthritis pain. Construct and interpret a 95% confidence interval for the difference in the proportion of people who would report decreased arthritis pain. That is our parameter. The true difference in the proportion people who would report decreased arthritis pain, where we have two independent groups. One got the placebo, one got the treatment. So we're looking at a two-sample Z interval for P1 minus P2. And we're looking at 95% confidence. So that's our first C, choose. The parameter, name the test, and the confidence level. I may have said T interval at the beginning, but I meant Z interval. For proportions, we use Z. Then I'm going to check my conditions. Randomly assign. So we can generalize. And we don't need 10% because we're doing an experiment. We're not randomly sampling. And then our large sample, we check N times P. So our N1 is 150. Our P hat 1 is 48 over 150. And our N2 is 100. And our P hat 2 is 21 over 100. So if I have 150 times 48 over 150, that's 48, which is greater than or equal to 10. And then my 150 times 102, that's 150 minus 48 over 150 is 102, which is greater than or equal to 10. And then 100 times 21 over 100 is 21, greater than or equal to 10. And 100 minus 21 is 79. And that equals 79, which is greater than or equal to 10. So we can use a normal model. So let's actually get some decimals for these. This one is obviously 0.21, and 48 divided by 150 is 0.32. So our calculate is going to be P hat 1 minus P hat 2. Okay, that's our point estimate, right? Plus or minus margin of error. Z star square root of P hat 1 minus P hat 1 over N1 plus P hat 2, 1 minus P hat 2 over N2, which ends up being 0.32 minus 0.21, plus or minus the Z star for 95% is 1.96. And we get 0.32 and 0.68 over 150 plus 0.21 times 0.79 over 100. We're going to plug this all in the calculator and get our two answers. So I have it all plugged in the calculator here. There you go. So you can see I can just plug it all in as one big long fraction, especially under the radical. I don't really need any parentheses. I know you can't see the whole thing, but just plug it in. 0.32 times 0.68 divided by 150, and then the plus, and then 0.21, 0.79 divided by 100. Notice that E negative 4, remember that means move the decimal place 4 times. So 0.0007 to 0.219. Okay, and then our conclusion. We are 95% confident the interval from 0.0007 to 0.219 captures the true difference in, what did we say? Proportion of people who would report decreased arthritis pain. And since our interval does not contain 0, it's really, 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 really close to 0, we could say there is convincing evidence. There is convincing evidence of a difference.